Good day everyone! Today we're going to talk about application of curve fitting. What is curve fitting? Curve fitting is the process of constructing a curve or mathematical function that has the best fit to a series of data points possibly subject to constraints. The main purpose of curve fitting is to theoretically describe experimental data with a model, function, or equation, and to find the parameters associated with this model. For example, in this table, it shows the US populations for the years 1970, 1980, 1990, and 2000. And there are two things we need to do. First, we need to find a cubic polynomial equation that best fits the given population data from 1970 to 2000. Then, we use this equation to estimate the population in 2010 and compare it to the actual population data. To find the cubic polynomial, we begin by fitting a quadratic polynomial function. This function is represented as p of x equals a sub 0 plus a sub 1x plus a sub 2x squared plus a sub 3x cubed. So where x represents the year and p of x represents the estimated population. To the points in 1970, the population was 205 million, in 1980, 227 million, in 1990, 249 million, and 2000, 282 million. So we have now the system of linear equations obtained by substituting these points into p of x is a sub 0 plus 1970 a sub 1 plus 1970 squared a sub 2 plus 1970 cubed a sub 3 equals 205 million. A sub 0 plus 1980 a sub 1 plus 1980 squared a sub 2 plus 1980 cubed a sub 3 equals 227 million. A sub 0 plus 1990 a sub 1 plus 1990 squared a sub 2 plus 1990 cubed a sub 3 equals 249 million. A sub 0 plus 2000 a sub 1 plus 2000 squared a sub 2 plus 2000 cubed a sub 3 equals 282 million. So we have now our linear equations. In order to get the approximate solution of the system, we have to write this into augmented matrix form by getting the coefficient and constant in our linear equation. So in the first row, we have 1, 1970, 3,880,900, 7,645,373,000, 205 million. In the second row, 1, 1980, 3,920,400, 7,762,392,000, and 227 million. In the third row, 1, 1990, 3,960,100, 7,880,599,000, and 249 million. In the fourth row, 1, 2,000, 4 million, 8 billion, and 282 million. Now, we use Gauss-Jordan elimination to get its reduced row echelon form of the augmented matrix. So, here's our reduced row echelon form. The approximate solution of the system is a sub 0 is approximately equal to negative 14,234,818,000,000. A sub 1 is approximately equal to 21,564,216,666.667. A sub 2 is approximately equal to negative 10,890,000. And A sub 3 is approximately equal to 1,833.3333, which means that an approximation of the polynomial function is p of x equals negative 14,234 $34,818,000,000 plus 21,564,216,666.667x minus 10,890,000 x squared plus 1,833.3333 x cubed. So, this is our cubic polynomial. Now, we're going to use P of x to evaluate the population in 2010. So, P of 2010 equals negative 14,234,818,000,000 plus 21,564,216,666.667 times 2010 minus 10,890,000 times 2010 squared plus 1,833.3333 times 2010 cubed. So, P of 2010 is approximately equal to 336,728,313.97. Therefore, evaluating the population in 2010 using the cubic polynomial equation give us an estimate of 336,728,313.97, which is higher than the actual population of 309 million. So that's all everyone. Thanks for watching.